All right, one more video in English. So there are some people, they comment in my videos in Portuguese that they have some questions and they have some doubts that they want to clarify on the tests that I make here in this channel. So if you're my English audience, please let me know in the comments if you want more videos in English like this, because I'll be very happy to make more videos in English. So please let me know in the comments below if you want more of that. Alright, so in this video I'm going to show you the FFT response of this DHO800 that I have. This is my own DHO800 because someone asked a question on the DHO900 video that I measured the bandwidth in time domain if it could go up to 800 megahertz, because that person has seen in the EV blog channel the teardown, and it looks like the hardware will be the same as the DHO4000. I believe it might be confused with the DHO1000 and 4000. I don't think the hardware is the same because of the sample rate. The sample rate here is 125 gigasamples, right? I believe the DHO1000 is much more than that, or at least double, I believe. And then the 4000 is up to 4 gigasample, right? So this test of how much frequency can you see on the FFT screen of the oscilloscope is directly related to the sample rate. So the sample rate is what's going to limit the performance of the device. This is why I usually go for higher sample rate oscilloscope. So I usually get one of these for 12 bits. 12 bits is good, it's fine for low signals. This guy is also powered by power bank, so you can power USB-C power bank and get isolated channels. That's why I have this guy here. But for frequency performance, I go with the MSO series from RIGOL. So I have a MSO 5000 in the lab, fully loaded, and I've just acquired an MSO 8000A, which is the new series of the MSO 8000. If you haven't seen RIGOL's website, usually they had the MSO 8000 for years now, but I believe this year they launched the MSO 8000A with new optimized hardware and software. So that's the one I got. It's arriving this week, and I'll have a bunch of videos about the MSO 8000A. So please let me know in the comments below if you want videos in English about this. I will also be producing videos in Portuguese. Usually if you activate the captions, YouTube, automatic translations, it's good enough for you to understand. But, in English it's always a plus. Okay, no more talking, let's start. So I'm inputting right now a 10 megahertz signal, and here's the thing. Usually on the MSO video, if you saw my MSO 5000 video, you saw that the FFT could go up to 2 gigahertz, right? The FFT on this guy here, Pixars, no. So it can only go up to, if I input 1 gigahertz here, it tells me that the upper limit is 625 megahertz, all right? So that's basically due to the sample rate. So the best performance you'll get out of this guy, and probably the DHO900, since the sample rate is the same, is 624.99 megahertz. 99999. Because 625 megahertz I've already tested. It doesn't show up on the screen. It's just a trace here and the limit, right? You'll see. So I'm going to just run a sweep, and then I'm going to do peak search, automatic peak search, for you to see it running. But the screen is bigger for the FFT. I just closed out the time domain just to isolate the FFT. You can see here the scale I'm on, 500 millivolts on channel 1, so you don't need the time domain to see the scale, right? So let's do a quick sweep. I'm going to configure here a sweep up to 624 megahertz. So 10 megahertz to 624. Let's see. All right, 50 ohm load as always, right? I'm using an RF signal generator. So basically, center frequency is 312 megahertz. So 312 megahertz, the center frequency. You can see it go up to 624 and then restarts, right? So you can actually see the signal if you're transmitting something up to that frequency. Because some people ask, oh, if I work with some 433 signals, RF signals, yes. 433 megahertz, you can clearly see on the FFT of this device. So let me stop the sweep now. Stopping the sweep, and now I'm going to import 433. So, and then now that we've seen that works, let me put span center, and then 433 megahertz is the center frequency. Span, let's put about 50 megahertz. Okay, 50 megahertz span. There's a signal, 433, right? Let me do a peak search, automatic peak search. Whoops, full. No, I don't want to change that. Yep, one peak, activate. Okay, so yeah, 433, exactly. You can actually measure. Let me get a better. Okay, now you can see it in the camera. Yep, 432,999 megahertz. You can clearly see the signal. Look, if I turn off the signal, there you go, and I'm transmitting 433. There you go. You can see a transmission. Of course, this amplitude is not correct because we know this device goes up to 70 megahertz. Okay, but for those using RF, usually you just want to know if your transmitter is working, right? That's what this device is good for, because for the price, come on, measuring RF with a very cheap device like this, I don't know, it's $300, $400, depending on, you know, taxes in your country. But yeah, that's too cheap to measure 433, right? You can do regular RF FFT measurement. It's very fast FFT. You see, this is really fast compared to, for example, the MSO series. The MSO series has a very slow FFT. So if you want like real time turning off and on, like look at this. You can clearly see the signal. So if you're transmitting, having problems, probably if you're having intermodulation, like you see here, you can detect intermodulation. You see, if this is intermodulation or not, you just turn off the signal, it's gone. So it could be intermodulation of your transmitter. It could be this device that is generating that intermodulation because it's out of its native bandwidth. So yeah, the device can go up to 624 megahertz as we just saw in the sweep. And if you want to operate it with 433, no worries. You can see your transmitter is working or not. Other than that, yep. So there you go. That's all for this video. Hope it's useful for you, helpful. Remember, sample rate. Sample rate is what's going to limit the oscilloscope frequency response. All right? See you in the next one.